Hi, I'm Carl Rosendahl with Carnegie Mellon's Entertainment Technology Center. I spoke at AR in Action last May about some of the work we've been doing with agents in AR at CMU, and I was excited when John invited me back to give an update. Unfortunately, our new semester starts this week, so I can't be there in person, but I thought about things that I'd like to share with you, and even though our offices are closed today, we're going to go in and look at an update from some of those projects. So we're seeing a lot of opportunities in augmented reality. Unlike virtual reality, which had a very steep adoption curve, you have to believe in it, buy it, install it, support it. Augmented reality is seeping into our lives. Applications like Pokemon Go and ARKit and ARCore enabling us to create all sorts of games and applications so that people get used to the idea of overlaying a digital world onto their reality. Additionally, we're using voice assistants like Google Home, Siri, Alexa, and getting used to interacting with the digital world in a really different way. So that creates a ton of opportunities. But what I'm really interested in doing is bringing agents and characters to life to live with us in our real world. Agents that can be teachers, companions, do tasks for us that maybe we couldn't accomplish on our own. So we've been doing a lot of prototyping about what these agents might be and how we interact with them. No one's here today. It's pitch black. The projects we do here at the ETC are done by master's students as part of a 2-year project-based curriculum that they do. They come together as teams of artists and engineers and work for 16 weeks at a time on a single project to see what they can accomplish. I'm based in our Silicon Valley campus, which is embedded inside of Electronic Arts. They've been really generous in giving us space here. So in the research we're doing with AR agents, there's 3 primary areas that we're looking at. And first is creating characters that are actually interesting and interactive to work with. The second is the hardware. We're hoping for a future where this is really the device that we use. Lightweight, untethered, with us all the time, and something that is socially acceptable to use. There aren't devices like that yet today, but they're on the way, and there are systems that we can certainly prototype with in the meantime to make that happen. And third is to create characters that we really want to interact with, not through menus and gestures, but something that we can actually have a social interaction with. Am I right?
You bet. You're right.
So to build those kinds of experiences, there's really 3 different areas that we pay attention to. And the first is this wild world out here. We need to understand what that is. And that comes down to initially scanning the world so that we can do tracking, so that we know where we are, where our objects in the world are, and we can mesh that all together as one. And that's really been a purview so far of the hardware manufacturers and giving us the tools to be able to do that. There's a long way to go though, because we don't yet understand what's in that world. And we'll see a lot of advances in machine learning and stuff that allow us to identify things in the world instead of just flat surfaces. The next thing we pay attention to are the characters themselves that we're building. And many times these are going to act as agents for us and do our bidding, but they have 3 different things that they need to be concerned with. 1, what is their role? Are they a butler for us? Are they a teacher? Are they a companion? Number 2, their personality. What persona do they have? Are they angry? Are they happy? Are they jovial? Are they introverts, extroverts? We have to pay attention to all of that kind of behavior for them. And finally, third, what are the interactions we can have with that character? What is allowed and what are the techniques we use for doing that? And then it's the third part, once we understand how the world and the agent work, is of course our user experience. And that is the definition of how our user interacts with the character and interacts with the world. And of course, how the character and the world interact together is an important part of that same equation. So we've been using that model for many of our AR projects. But this semester, we decided to really push on the interaction with the character itself and do that specifically using natural language processing. We've been using NLP as consumers for a while with Google Home and Alexa and Siri, and the experience hasn't always been that great, like this example. Hey Google, what's my wife's name?
You told me that your wife's name is Sarah.
Hey Google, what's my wife's phone number? But we do know that speech is going to be a very important part of how we interact with characters. So this past semester we had a team of 5 students who are a combination of engineers, artists, animators, working together to work on this problem. The project definition itself was pretty open-ended. They got to define what the role of the agent would be, what its persona would be, and then explore deeply more about that. The big criteria was they had to use natural language processing. So let's take a flash back into the past so they can introduce themselves to you. Hello, Charlie.
Hi! Hi, I'm Yong, the producer for this project.
I'm Shane, the UX designer and artist.
I'm Ming, I'm the designer.
I'm Angie, the co-producer and programmer.
I'm Yang, I'm the programmer of this team.
Project Charlie is it aims to explore how we can use emerging technologies like AR, AI, natural language interaction to create new experiences. So to do that, we created like a virtual character who lives in the Microsoft HoloLens, and she likes taking pictures. So she will guide you through the world to accomplish that task.
So the team designed an experience around a little girl named Charlie. She's about 5 years old and 5 inches tall. She lives on a desktop and loves to have people come by to visit and take pictures with her that she can share on her Twitter feed. Let's take a look at the demo.
Hi.
Wow, you are here. Are you Pumpkin?
No, I'm not.
May I know your name?
I'm Andrew. What's your name?
Charlie. Could you please tell me what's your name?
Andrew.
Hello, Andrew.
Hi Charlie, how old are you?
I'm 6, turning 7. How about you?
I'm 2000.
Wow, you are older than my cat.
Do you have a cat?
Yes, it's in a room, running around every day. Do you see it?
Oh yes.
Indeed. What is your favorite city?
New York City.
Have you ever been there?
Yes, many times.
So, why is it your favorite city?
There's lots of tall buildings.
Sure. Okay, we are having a party, Andrew, now. Would you like to join us?
Let me think.
Please, please join my party.
What's the party about?
It's a secret.
Okay, fine. I'll join your party.
Great, follow me. Can you help me take a photo?
Of course.
Thank you. Andrew, look where we are now. New York. Do you like it?
Not really.
What would you prefer?
How about Times Square?
Do you like this view?
Wow, that looks fantastic.
I really love trick-or-treating. I get so many candies. Do you like this view?
Wow, that looks fantastic.
Great. Thank you so much. Are you ready, Andrew?
Always.
Great. 1, 2, 3, done.
So, how does Charlie work? She's got a brain, not one like this. Hers is made out of Unity. So, here's Charlie. The main app is on a HoloLens, and HoloLens has Cortana built into it, so they're using Cortana to do the speech-to-text conversion of what the user says. That text is sent up to Dialogflow, which is Google's natural language processing engine that you can use, where it's converted from text to context. That context comes back down to Unity, her brain, as a JSON file. Unity is running Playmaker, which is a state machine, which really acts as Charlie's memory. The state machine keeps track of what the user has said about favorite places, favorite colors, their name, and where through the experience the user is. Unity then uses information from the state machine, talks to Dialogflow, and gets a response for Charlie to present to the user. The final step, the text-to-speech, is done by Watson, IBM's product. Watson has a really good text-to-speech engine that allows you to change the tonality of the character's voice and add in emotional intonations to it. Then Unity drives the animation that Charlie performs while she's responding to you. Let's get to some of the specific lessons that were learned on this project. I'm going to do a couple categories, one about the character design and one about natural language processing itself. There are lots of other lessons we learned, but we're going to focus on these. We've learned on a lot of these projects that the design of the character needs to reflect the character's abilities. People come in with a certain set of expectations and stereotypes for a character's design that will determine what they believe the character is capable of doing. We've done projects with characters that are humans, that are aliens, that are robots, that are alien robots, and people bring a certain set of expectations to each one of those. For Charlie, the team decided to use a little girl. If she was an adult, we would have expectations of a broad base of knowledge and experiences that she could talk to us about. So by designing Charlie to be a young character at about 5 years old, we hoped that that would lower the expectations of the audience for what Charlie knew, for what her attention span would be, and how she would behave in certain situations. So there was another benefit that the team learned through this. Natural language processing is far from perfect. There were issues with recognizing words. There were issues with figuring out the context of what people said. There were a lot of errors happening in the process. So there were times where the system just didn't know what to do. Because we had this little girl, she could suddenly become bored or distracted or do something else completely because that's what little kids do. And it was a great form of error masking. Because of the pipeline we had, there was also a lot of latency between the user and Charlie's response. And that led to confusion a few times, where people would interrupt and speak over her because they weren't sure what she was doing. So animation is a great solution for part of that. We can signal to the user if Charlie is paying attention to you, if she's thinking, if she's bored or doing something else. And that got us through the latency issues a number of times. Other times people would start talking before Charlie had had a chance to respond, and it sounded like an interruption in the dialogue. So the team had Charlie just be quiet as soon as she was interrupted. There are quite a few lessons we learned just from the natural language interaction part of this project. First and foremost, this is far from a solved problem. Essentially building a chatbot for conversation and putting that into an AR agent is a really difficult thing. You have to handcraft all the responses that the character does. We haven't gotten to the point yet where machine learning has solved this problem for us. So in the case of Charlie, she had a very finite domain of knowledge about her environment and things she was interested in, but users very often went off track. So the team had to design ways to bring the user back in. And one of the things they did is by creating a rich environment of objects, people were interested in talking to Charlie about what was in her world rather than their own. And she had backstory and knowledge about all the things in her world. Having a variety of responses is also really important. There are many times where the user would be confused or Charlie would be confused and they kept talking about the same thing. If she gave the same response more than once, the magic was lost. So the team had to fashion a wide variety of responses to similar situations and similar questions that Charlie could toggle through to create a more interesting and robust experience. So there's one really interesting surprise with user expectations for natural language. The people who had experience with voice interactions, whether it was Google Home or Alexa or something else, they tended to have very low expectations of what the experience could be. And because of that, would not converse with Charlie, they would just be very terse and give one-word answers to things. It was really disappointing because the system was designed to be much more conversational. People who came in and tried out Charlie who had not had experience with other voice systems just assumed that it could do anything and had a much better experience for that. I think that will change over time as voice systems get better and we get used to using them more, but it was very interesting to see that artifact of the time that we are in right now. So those are some of the lessons we learned about building a character and having natural language interaction. There's a lot of work still to do in this area, and quite a while, I think, before this really can be the kind of experience we want with characters living in our world. Okay, a few closing thoughts as I pack up from what turned out to be a pretty long day of shooting. First thought, we're going to need a lot more than just voice if we're going to interact with characters. As cool as it is to be able to speak to them, it's far from a complete solution. We need things that help you figure out the intent. It was really difficult for Charlie to know what you were thinking and what you were doing just by what your voice is, because it's never clear. Even as humans, we never know, right? So being able to do gaze tracking so we know what you're looking at, what your focus is, being able to understand gestures and not Microsoft gestures because those are inaccessible to people, but the natural, normal kind of gestures that we use every day to help us communicate. Those sorts of things are going to be crucial to developing characters and interactions with characters that we can really have a social experience with in augmented reality. Okay, next item as I collect my thoughts to put away. We chose a really difficult thing for Charlie to do. It was a general conversational experience with not a lot of specific things. I think really important, at least in the near future, is for agents to have very specific roles, specific tasks that they're trying to deal with so that their knowledge base can be very constrained and the user expects that knowledge base to be constrained. So I think future projects for a while we're going to be really choosing a very, very tightly defined role for characters. Third thought, much more real-world interactions. This project was really a lot about the user and the character, Charlie, communicating with each other and interacting, but really did not interact with the world around us the way that we want to have it. And if it's going to be augmented reality, it really needs to interact with this world. So I think future projects really focusing tightly on that kind of interaction, and we're going to rely heavily on hardware and software makers to give us the kinds of image recognition tools and object recognition tools that allow us to understand what is in our environment beyond just surfaces, but really understand the items and the things in there and how we can manipulate them. Okay, fourth and final, can't believe I actually did a sock puppet. I hope you'll forgive me for that. But thank you for including me in AR in action this year.